Hey, what's up guys? Welcome back to the Mr. Fix-It channel. Today I'm building a milling attachment for my old lathe here. Yeah, stay tuned for this chaos.
I was sitting out there in the shed one evening, not doing too much of nothing, just kind of staring at the wall.
Alright, so I already purchased a second-hand cross slide. This is a little bit bigger than I really need, but I got this at a great deal, and it's very well made. It's very precise. So this is one we use for, what is this, the Z axis or the Y? I don't know. One of the axes, whatever. And then I got a second-hand machine vise. This is seen better days, but yet again, I acquired this at a very good price. This is most of the work as far as like building a milling attachment for a lathe. So if you're just going to build this thing completely from scratch, you would have weeks, maybe even months involved in building just these two things alone. So I skipped all that and I purchased these two parts to begin with. Now, the one thing that I don't have is the angle plate that these attach to, to adapt these to the lathe. So I bought this 4" by 1" hot rolled flat bar, and I'm essentially going to weld these together like so, and then this will attach to here, and this will attach to here, and you see where I'm going with that? So this is how I'm making my lathe milling attachment. So I got the first two pieces cut out. One's a little shorter than the other. I got to put this in the forge jaw, and I need to face this off perfectly flat because this is going to go down on where the compound rest goes. So instead of this, I'm going to have this attachment. So I'm going to have to face that off, and I'm going to have to bore a few holes in this, and then I need to turn, well, you'll see once we get into the video. I got to do quite a bit of work to this base plate here before I can weld this onto here. Now I don't know if I'm going to have to run gussets up here. I'm assuming I'm going to have to, but basically weld this together to that, and then this will sit on the lathe, and then I got to figure out how to attach that to that. So that's where we're going with this. Alright, what I'm going to build this angle plate out of is this 4" by 1" hot rolled steel bar. I need to cut off, my first piece is going to be 4.5 inches long, so let's get this heavy thing up in here. I wish I had room in my shop for a bandsaw, because that would definitely make this a lot easier to cut. This is how I got to do it, right? You gotta love those projects where you need 3 hands. All right, let me regroup here. I'm doing all this effort setting this in here, and I'm going to have to change a blade because the blade isn't long enough to get through this entire piece. Alright, I got to swap this blade out because it's not going to get through that 4 inches. This thing must weigh 50 pounds. Alright, that's about as straight as I can make it. Trip the breaker. Alright, so I took some measurements of the base underneath the compound rest. So this is the center post that that the compound pivots around, and this is how tall that is. So I basically need to drill a 1/2 inch hole in this, and it needs to be basically a 1/2 inch deep. I also got the bolt spacing because there's 2 bolts to hold this on, so I need to grab a felt pen. So I need to measure approximately where this bolt hole, this is going to be off center, so it's not going to be dead in the center, because I want this to hang over the edge just a little bit. So I'm going to put the center bolt there roughly, and then there's going to be 2 holes for the 2 bolts. So I need to do some measuring here. There's also the base circle, you know, the base of the thing that's got the protractor on it. So I basically need to, so it's 3 3/8 inches of the circle here. So I need to find 3 3/8 circle and then place it on here to where one edge is at the one edge of the circle, and then put this center hole in the center of that circle. Now on the lathe there is a screw that sticks up slightly, so this can't sit flush on that base circle. So once I determine this circle that I need on here, I need to turn it down. I need to turn the thickness of this down, but leave that circle full thickness. So if that doesn't make sense, it'll make sense once I start machining this. So I gotta take some measurements, I gotta figure out where these holes are going, and I gotta offset this in the forejaw to do what I gotta do here. This is gonna mark my base circle, the center of it. Now I need the bolt spacing, which is 2.5 inches, so that's 1.25 inches on either side. So I'll go ahead and mark these roughly there and roughly there, and these need to be, you know, they don't have to be, but it would be nice if these were perpendicular to that center line this way. So I need square, and we'll line these up with that center mark. So it looks like they're going to go right here. So go ahead and center punch those, get them permanently marked. Okay, now I need to set this in the forejaw and offset it so that this mark here is in the center. Now I learned this trick off a YouTuber called Blondie Hacks. She's got a lot of great content on her channel. She doesn't know I'm saying that, I'm just saying that. But if you take your lathe center and you put it in your tailstock, and you put the point of your center in your center punch mark in your forejaw, you can use your dial indicator to dial that punch mark right into the center. That's my high spot, so that needs to go down. Less than a thou. Alright. So snug the rest of these up here. Alright, so now I got my base circle center in the center of my lathe using this method. So see the step I put on here? So once it gets mounted where the compound rest is, it needs to be able to clear these screws here as I pivot it. So that's the need for that step. So hopefully that's high enough to clear those. That's 160 thousandths from there to there. So a little more than 1/8 of an inch. Now to put the hole in the center here. Start with the center drill. Just going to use the markings on the quill of my tailstock here to measure out a 1/2 inch deep hole. Alright, I'm going to the next size below 1/2 inch because I want to use a boring bar and get an accurate 1/2 inch hole, because drill bits tend to drill oversized sometimes. Going a little bit deeper than a 1/2 inch because of the point on the end of the drill. Yeah, you got this point on here. Okay, okay, I'll raise it up. I'll raise the tool cutter up. Okay, you got it. Whatever you want here, buddy. Whatever you want. So I'm just going to use a drill bit as a gauge pin here. And I measured this with the micrometer, and it is like 2 thousandths under 1/2 inch, so 498 thousandths. I measured that pin at 499 thousandths, so this needs to be an easy slip fit into that hole. So unfortunately, if I wanted to check the fitment of this hole to the pin underneath my compound rest, I would have to unthread my chuck and then take the compound off and then test it that way. So that's why I'm going to use a drill bit, because I don't own an expensive set of pin gauges. So we're doing it this way. Low tech. What I've learned about machining is a lot of machining is just being patient and taking your time. So that is a nice slip fit on that drill bit, which measured 998 according to my little micrometer here. 997 and 8/10 to be exact. So we should be good here. So throw a little chamfer on that hole because we live in a civilized society, and throw a little chamfer on the outside of that base circle. Alright, now the next step on this is I got to drill the 2 bolt holes. right on there. In all honesty, I didn't realize that the screws that are sticking up out of this aren't threaded all the way in, so I had to take off a little bit off of this, so it's about 200 thou shorter. Yeah, those screws weren't threaded all the way down, so I had to take that much off of these, but it basically just bolted right on there. Now it's got to get the upright piece to make this an angle plate. And then the next big challenge is figuring out how to attach the vise to the cross slide, because I want to be able to pivot the vise this way. So yeah, next big challenge there. Alright, before I mark anything, I need to tram this piece in. So I got my indicator on here and these screws are snug, so I basically just need to lock the carriage down where it's at. So I just need to tap this until the needle stops moving, essentially. So now this edge is perpendicular with the lathe. Go ahead and tighten this down. Make sure nothing moved. It did just a tad, damn it. Okay, right there, it looks good. But an easier way to do it is you can put your faceplate on and butt that up to your faceplate. Tighten it down. That's going to get it just as square. So a couple different ways to do it. If you don't have a faceplate, you can use a dial indicator. But I'm going to use my faceplate. I went ahead and faced off this part on both sides. I'm going to use my faceplate. I'm going to clamp this here and weld the back side, and that should keep it mostly square. So I don't have to take off a whole bunch with the fly cutter. Okay, before I do any welding, I need to bevel this edge. So let me go cut a big bevel on that, and then we can come back, clamp that in, and get ready to weld. Alright, big ass bevel in there. The steel is so thick, I'm probably going to have to preheat it with a little torch. Although I hate getting that much heat around my lathe, but well, unfortunately, this warped really bad. So I have to cut quite a bit out. Hopefully I can save it and I don't have to start all over. Alright, now we find out if my fly cutter is going to work. This may take a while. It's working. This is gonna take a long time. Ugh. Alright, so this did work. However, halfway through I ended up breaking my cutter off because I got a little greedy on how much feed I was putting into it. So I had to kind of improvise and adapt there. So this came out all the way. My cutter didn't quite reach the bottom and it didn't quite reach the very top there, so I got to kind of grind that off. But this section is nice and smooth, so that should be nice and straight that way. I was keeping track of my movements with my dial indicator here on the carriage. My goodness, that took a couple of hours. And also, when I took this off, I ended up dropping one of these nuts down here somewhere. And yeah, I cannot find it. I've looked under there, I've looked under there, I've looked in that crack back there. Whatever. So the next task at hand is to get the angle plate off of there and start getting this stuff attached to it. Alright, so there was the seam here where I welded this piece to this piece right here. Well, turns out that that seam is right where these bolts are going to bolt down at. And if I had this to do over again, I wouldn't have set this plate on top of this plate. I would have butted, this would have been full length from here to here, and I would have butted it there and welded it there. So keep that in mind if you ever decide to do something like this, that you don't want a weld seam on the face here. I had to grind that seam out a little deeper and re-weld that. And now I got to put it back on the machine and face this back off again. Well, this escalated quickly. Yeah, I crashed my lathe. I had the crossfeed all the way back this way to get ready for a cut, and my lever was in the wrong position. So let me fix this now. So luckily, when it backed off, it pushed this gear off of the crossfeed lead screw, and the key started to come out, and it was kind of jammed up there. I was able to get the machine shut off before it caused any real damage. I think. I'm crossing my fingers that that's all that happened. So I gotta get this all put back together and see if it still works. I was really afraid I screwed something up majorly, because although you can buy these parts, they are stupid expensive. Oh my god. So it marred this keyway up just a little bit. So I'm just trying to get the burr out of there. I run the key on a file and took the burr off of it. You can see the hit it took right there. It almost sheared off. Let's see if this will fit in here now. Yeah, okay. I'm going to put the damaged part on the outside. There's a little burr inside here where this spun around. So I got that filed down. Oh my god, it still fits together. Yeah, this lead screw, that's almost $400. This little guy here, yeah, I'm sure that's $100. Who knows? Oh my god. Alright, so gotta slip this back together. This gear's got to go in after I put it into the carriage, so alright. But you guys didn't know this was going to be a lathe repair video also. And so let me put the key in. Hopefully it'll stay put. And I gotta drop the gear in. When I first got this lathe, I found a manual, a free one on the internet, and I bought, I downloaded it. And first thing I did was I started taking the machine apart so that I would know what I was in for, if any damage or if I had to replace anything. And that's why it's a good thing to have a manual on everything you own. Where's my flashlight? I swear the flashlight's the hardest thing to find in this shop. Drives me crazy. There we go. That's back together. Maybe not. The key's kind of halfway poking out there. I wonder why that don't sit down in there like it should. There we go. That's how it should be. Okay, now this piece goes on. And we got the little dial. And we get a nut. The big nut goes on the inside. This lathe had some damage to it when I got it. I had to do some repairs to it. I think what had happened is it had tipped over and landed on all the hand wheels and messed up a bunch of stuff, because I had to repair this shaft and a couple other things on it when I first got it years ago. It's been working good ever since. So I have to go back through and adjust all this, because these nuts determine the backlash here. As in if these nuts aren't adjusted right, there's a bunch of play in the screw. So I'll have to go back and probably adjust all this later, but as long as it still works, I will be satisfied. Okay, there's hardly any in and out play, and that still turns free. That's how we like it. Although I didn't think about it, I should have put a drop of oil in there while I had that apart. Shit. Alright, $1 million question. Is it fixed? Yes. Oh my God, okay. Let's not do that again. So when the blade comes back around the backside, it always leaves this crescent moon shape. I don't know, whatever. So, see where I welded it? It's that shiny spot. Now I got to transfer these holes onto this and drill and tap. Unfortunately, I can only use the bottom 4 holes on this, but that's what we got. That's where we're going. So I guess if I really wanted to, I could drill 2 more here, but we'll see. That might be something I do in the future. Right now we got these 4 holes. Let's transfer punch these and get these drilled and tapped. Well, if you don't have the right size transfer punch and you have a lathe, I guess you make one. There's 4 holes. And drill and tap those now. Have you ever been there before? Yeah, at least I got it out. I had to go buy another one. Jesus. When a project starts dragging on like this, I start to get a little careless sometimes. Need to stop that. Alright, let's see what other kind of surprises I'm going to have here. to buy bolts. These were $1 a piece. The correct size Allen key here. Alright, there's that. Okay, I think that was the easier bit. Now, I know I said earlier that I wanted this vise to be able to rotate. Unfortunately, that's not going to be doable because of where this nut is for that lead screw. I was going to have to make a pin that fits in this and then slot holes in this, which, I mean, you really need a rotary table and a milling machine, so that's not going to happen. What is, however, going to happen is I need to bolt this onto here. There are holes already threaded in this, but because of where they're located, they're going to be in these T-slots, so I can't use these. So what I need to do is I need to drill 4 new bolt holes through this and into this. So I have these 4 bolts here that I have to accommodate for right here, and I can't come into this dovetail section with the screws, so gotta do some measuring. I'm going to pull out the nut for the lead screw on this just so I can have this sitting flat. So I'm going to start by doing that, because I got to line these two up, you know, and clamp them together like I did the cross slide. But this is where we're at. Alright, just for orientation's sake, the slot for the backlash adjuster is there. Okay, so now take that off, and that'll set flat. And then I can set this vise up here, line it up, and get it in the drill press and bore 4 holes. I think I might take the jaw off so that I can put the holes underneath where the jaw's at. 1.3. Right there. Right there. Right there. And right there. Those are going to be my 4 bolt mounting locations. Now I can clamp this together, take it over the drill press, and wreck some more shit. One thing I just realized is those going to get into the damn T-nuts. Damn it, it might. So many variables that you got to account for when you're doing this kind of stuff. I've already started drilling them. I might as well continue. It may just clear it though. But I got to countersink it as long as I don't countersink below that T-nut slot. And another thing is, when you're doing this for YouTube, you're constantly thinking about what to say instead of thinking about what to do. And that's really difficult to figure out, you know, everything you need to do because you're focusing on the camera. So that being said, I might want to move these 2 holes in just in case these don't work out. Then I won't have to redo all 4 of them. So I remark these 2 holes a little closer to the center. Hopefully get out of that T-nut slot. These over here, I'm just going to go ahead and let them ride. They might squeeze past, but if they don't, we'll figure that out when we get there. Oh, well, you get the idea. There'll be more of this. Very repetitive, boring to watch. So I got to countersink these and drill about the size, all that, thread, blah blah blah. Alright, getting down to the last couple things here. there's something wrong in that hole. I'll have to pull this out and have a look in there. Threads got messed up or something. Hold on. Alright, I got it figured out. The threads on this $1 screw that I bought were jacked up. You can't buy anything anymore. I wanted the black ones. Hardened ones, not these stainless ones. But they didn't have enough. I needed 8 of them. There we go. So just a little bit of cleanup on these parts and final assembly. Oh, been a long time getting here. Alright, let's assemble this pile of scrap metal here. Still need to make a handle for this vise, but I'll do that later off camera. Alright. Well, that's it in a nutshell. I guess let's attach it onto the lathe and see if it'll do what I hope it'll do. Oh my God, there's some gravity in this thing. Jesus. Oh, that's heavy. It's kind of a massive thing. Sorry about the glare in the background from that window, but there it is. Very rigid. I need to tighten these gibs up. And yeah. Alright, so this is an important step because you got to ensure that this cross slide is perfectly in line. So I got it set up in the forge jaw here. I got it sitting flat against the surface of the forge jaw. I got everything locked down so it doesn't move. And I'm going to measure the distance with my dial indicator on the carriage from here to here so I can align this the best I can. Now, you need to understand if you have any wear in your lathe bed that's going to translate into this if you set this at 0. So I know that I have 3/1000ths of wear. The carriage will move back 3 thou from this point to this point. That's the wear it's in the bed of this. So I got to count for that. So I'm going to measure from there all the way down to the other end. So that says 2.5 thou, 3 thou, 2.5, 3 thou there. And all the way down here, that says 0. So snug the bolts up and then tap this around until you get, if there's no wear in your bed, then it would be 0 all the way across here. But since I know that I have some wear, I need to account for that. So this is where we're at. The next step is get the vise mounted up here and do the exact same step to the vise. And to make this even more accurate, because it's been a while since I checked the wear in my lathe, I can go and recheck that wear again, mark precisely how much wear there is between these 2 points, and then translate that exactly into these parts, and that'll get it as accurate as this lathe can possibly get it. Now, to go a step further, once I get this mounted back to the cross slide, I can put a parallel in here and I can check it off the bed, the back of the bed back there, which the least amount of wear is going to be on the back side of the bed. So I can check, put the dial indicator, set it there, and then check across a parallel here in the jaws and adjust this way. So let me show you that. I'm going to go ahead and do that. I'll show you that too. Now, I do apologize about the glare behind the window there, but you can see I got the jaw facing back behind the lathe. I've got this 1-inch precision ground gauge bar. You know, this sticking out is about 6 inches. Alright, you can see I'm set to 0 there. And when I sweep this, you can see I'm about a half a thou over the course of 6 inches. So that's, I mean, way more accurate than I ever need it to be. So that's set up now. And you can also use the same technique with the dial indicator to set the angle this way. Now it's all set up and ready to use. Alright, so I need to test this thing. I got a couple milling bits here, but I need something to mill. And what I got, I broke down and bought one of these quick change tool post holder from China. Been wanting one of these for quite a long time. And what you got to do here is you got to machine this block to fit in your tool post. So this may be my very first project here. So I got to fit it, make it fit that. So let's do that. Alright, so fair warning, math is not my strong suit, so yeah, let's see what happens here. Just going to take about 5 thou off the first cut here just to see what happens. Alright, here goes nothing. Looks like it's cutting. Feeding this by hand. Alright, well there's 5 thou off. That seemed pretty good. I don't want to push it too far though. Let's try cutting the other way now. Take another 5 thou off and bring it back this way. More like 6, but oh well. Now this is going to be putting upward force on the whole assembly, so oh, it's cutting just fine. Oh yeah, I think we're going to be okay. Ooh, what was that? Grabbed a little bit there. I'm not sure what that was about. I think still tight. it pushed the carriage back. I didn't like that little jump. Alright, I'm going to try power feed. So I got to take 403 off of this side. And then 5 thou each pass is going to take a while. It just actually dawned on me that I am milling with my lathe. I got my gibs way too tight on my cross slide. Let me adjust those. I'm going to go 10 thou this time, but I'm going to feed it by hand so I can feel it. Seems to be okay. That was 10 thou pass. Let's try a 15 thou pass. This is way more rigid than my drill press setup. Now, I know you're not supposed to hold the tool cutter in the chuck. I don't have any tool holders, so this is just how I'm going to do it for this moment. Cut on the way back this time under power. The way I don't have to crank this thing by hand every time. I don't like those little jumps that it does. It's like it gets a chip caught in it or something. So this setup, it's inherently not rigid because look at the distance between where the cutter is and where it's mounted. So there's a rocking moment here. I helped a little bit by taking out one of the grub adjusters and putting a bolt in to lock this down so it can't move up and down. But this has to move, so I can't lock this down. This is not a milling machine. This is a lathe. This attachment allowed me to do milling type stuff, but I can't do it quickly, or can't take deep heavy cuts. So I'm going to go ahead and finish this piece. It needs to be shaped like a T-nut off camera because this video is already going to be quite long, and I'll come back when it's finished, or if my lathe explodes we'll talk about that. So let me machine this, see what happens. Alright, so it works. I noticed that when I would cut from the bottom this way, I could cut 30-35 thou off on each pass. So for some reason when I'm end milling here, it's wanting to push the carriage back. So gotta be careful with like facing cuts. I think it would have done a lot better if I have new cutters. I bought these secondhand and they are dull. I started with this one. I tried to use this one, but this one is more dull than this one. So some new cutters need to be ordered up. These are not cheap, so that's why I bought a couple secondhand, but they did do the job. But as far as making this, it works. I mean, there is no possible way to make a T-nut like this in a lathe. You have to have a milling machine for that. So all in all, I think this is a success. You can definitely do this with a lathe and the drill press. You just got to buy these two pieces. Now, if you had a milling machine, you could make these two pieces, but why would you make a milling attachment for a lathe if you have a milling machine? So really all you got to do is have this angle plate and be able to have some way to make this plate straight up and down with your lathe. So this opens up a whole new world for me. And if you're wondering why this doesn't look like the part I started with, it's because never mind about that. So yeah, now I can hook up my new tool post and I have a new attachment for my lathe. So this was a whole lot of screwing around. This took a whole lot of time to do. Machining work is a very slow, tedious process. So if you guys like this video, please give me a thumbs up. Consider subscribing and don't be afraid to build it. Thanks for watching.